Enterococcus faecalis, Wikipedia audio. Enterococcus faecalis, formerly classified as part of the group D Streptococcus system, is a gram-positive, commensal bacterium inhabiting the gastrointestinal tracts of humans and other mammals. Like other species in the genus Enterococcus, E. faecalis can cause life-threatening infections in humans, especially in the nosocomial environment, where the naturally high levels of antibiotic resistance found in E. faecalis contribute to its pathogenicity. E. faecalis has been frequently found in reinfected root canal treated teeth in prevalence values ranging from 30% to 90% of the cases. Reinfected root canal treated teeth are about 9 times more likely to harbor E. faecalis than cases of primary infections. E. faecalis is a non-motile microbe. It ferments glucose without gas production, and does not produce a catalase reaction with hydrogen peroxide. It can produce a pseudo-catalase reaction if grown on blood agar. The reaction is usually weak. It produces a reduction of litmus milk, but does not liquefy gelatin. It shows consistent growth throughout nutrient broth, which is consistent with being a facultative anaerobe. They catabolize a variety of energy sources including glycerol, lactate, malate, citrate, arginine, agmatine, and many keto acids. Enterococci survive very harsh environments including extremely alkaline pH and salt concentrations. They resist bile salts, detergents, heavy metals, ethanol, azide, and desiccation. They can grow in the range of 10 to 45 degrees Celsius and survive at temperatures of 60 degrees Celsius for 30 minutes. E. faecalis can cause endocarditis and septicemia, urinary tract infections, meningitis, and other infections in humans. Several virulence factors are thought to contribute to E. faecalis infections. A plasmid-encoded hemolysin, called the cytolysin, is important for pathogenesis in animal models of infection, and the cytolysin in combination with high-level gentamicin resistance is associated with a 5-fold increase in risk of death in human bacteremia patients. A plasmid-encoded adhesin called aggregation substance is also important for virulence in animal models of infection. Physiology. E. faecalis is resistant to many commonly used antimicrobial agents. Resistance to vancomycin in E. faecalis is becoming more common. Treatment options for vancomycin-resistant E. faecalis include nitrofurantoin, linezolid, and daptomycin, although ampicillin is preferred if the bacteria are susceptible. Quinupristin/dalfapristin can be used to treat Enterococcus faecium but not E. faecalis. In root canal treatments, naocl and chlorhexidine are used to fight E. faecalis before isolating the canal. However, recent studies determined that naocl or CHX showed low ability to eliminate E. faecalis. Prior to 1984, Enterococci were members of the genus Streptococcus, thus, E. faecalis was known as Streptococcus faecalis. In 2013, a combination of cold denaturation and NMR spectroscopy was used to show detailed insights into the unfolding of the E. faecalis homodimeric repressor protein CYLR2. The E. faecalis genome consists of 3.22 million base pairs with 3,113 protein-coding genes. Bacterial small RNAs play important roles in many cellular processes. 11 small RNAs have been experimentally characterized in E. faecalis V583 and detected in various growth phases. 5 of them have been shown to be involved in stress response and virulence. A genome-wide sRNA study suggested that some sRNAs are linked to the antibiotic resistance and stress response in another Enterococcus, E. faecium. Pathogenesis. Antibacterial resistance. Survival and virulence factors. Historical. Genome structure. Small RNA.